Dear students, we are on the CEC Gurukul lecture and we are in the series of electronic components, and today's topic is the sensor, which is the most important component nowadays in the electronic equipments. You see that sensors are used in almost all the equipments. So we are discussing what are the sensors, and sensors are having the some specification that we have defined, and what are the attributes of the sensors that we have defined in the previous lecture. Now, what are the components of the sensor and how the sensor are classified, we will discuss in this lecture. So, what are the main component of a sensor? The sensor having the three main component. Basically, it depends upon the application where we are using the sensor. So, the sensing selection contains the sensor itself, which is based on the particular technology. So, variety of technology means one can select a sensor technology which fits in its application. So, on the basis of the application, we use the sensor. We use the components of the sensor. The processing circuitry converts the physical variable into an electrical variable. Means we are giving the input in the form of the physical parameters and the output we are getting in the form of the electrical parameters. So, the signal output contains the electronic connected to the control system. Input we give in the physical form, then we are having a sensing system, then the output we are getting in the control system. So, these three components are used in the sensing system. What are the classification of the sensor? Basically, sensors are classified in the several ways. Like in a first classification of the sensors are divided into two parts. Now, one is the active sensors, second is the passive sensors. What are the active sensors? Active, which require an external excitation signal or a power signal. And what are the passive sensors? Which do not require any external power signal and directly generate the output response. So, one type of classification is the active and the passive sensors. Active sensors which require the external excitation signal or the power signal, whereas the passive sensors do not require an external power signal. It directly generates the output response. Moreover, this type of sensor produces the output signal with the help of external excitation supply, which is given to as an input. The on-physical properties of the sensor varies with respect to the applied external effect. Therefore, it is also called the self-generating sensors. Sometimes feedback given to as an input, so that is a self-generating sensors. An example of these sensors, active sensors, are LVDT and the strain gauge. Next is the passive sensors. This type of sensor produces the output signal without the help of external excitation supply. So, they do not need the extra stimulus or the voltage. They give the output in the terms of automatic form. So, example of this type of sensors are thermocouple, which generates a voltage value corresponding to the heat, which heat we can giving, then the voltage it can be output in the form of the voltage, and it does not require any external power supply. Directly it gives the output. The other type of classification which based upon means of the detection used in the sensor. What type of where we are using what is the detection application of the sensor? Some of the detectors are electric, biological, chemical and the radioactive detectors. In another classification, the which based upon the conservation phenomena. and moreover which based upon the conversion phenomena also, the input and output, how we convert the input into the output. Some of the common conversion phenomena are photoelectric, thermoelectric, electrochemical, electromagnetic, thermo-optic, etc. So the classification can be done by on the basis of the conversion, means we are converting the photons into the electric signal, we convert the thermal into the electric signal, we convert the electric signal into the chemical signal, we convert the electromagnetic signal, and moreover we convert the thermal signal into the optical form. So on the basis of that the sensors are classified. In the final conversion, we are having the analog and the digital sensors. Analog, as we all know, that the output produced in the form of the analogs output, and which is a continuous output signal, that in the form of the voltage, and with voltage with respect to the quantity being measured, that is the continuous signal we get in the form of the output in the analog signal. In the digital sensors, the contrast to the analog sensors work with the discrete or the digital data. Continuous output we will not get, but in the form of the discrete or the digital data, means 0 and 1, we get the output in this form. The data is digital sensors and which used to conversion and transmission, which is in the digital in nature, like output in the form of the 0. In the analog system, the output is in the form of 0 to 5 volt. Here a range is defined, but in the digital the range is not defined, but the values are defined 0 and 1. So in the analog sensor, which produce a continuous signal with respect to the time with analog output, which is called the analog sensor. The analog output generated is proportional to the measured or the input given to the system. Generally, the analog voltage in the range given 0 to 5 volt or the current is produced as an output. The various physical parameters like temperature, stress, pressure and displacement are the example of the continuous signal. The output of input we will get in the continuous signal, that is in the analog form. For example are the accelerometer, speed sensor, pressure sensors, light sensor and temperature sensors are the analog sensors. Next is the digital sensors, which convert and transmitted digitally. The data is converted and transmitted digitally and it is called the digital sensor, like the data is converted into bits and bytes. So digital signals will be non-continuous with the time and it can be represented in the bits for the serial transmission and bytes for the parallel transmission. So it produces the discrete output signal. Digital signal produces the digital output signal, bit for the when we are having the non-continuous with respect to the time, and the bits for the serial transmission, and when we are getting the parallel transmission, the output in form of the bytes. The measuring quantity will be represented in the digital format, like 0 and 1, that is in the form of logic 1 or the logic 0, or 1 on and 0 is off. The digital sensor consists of the sensor, cable and the transmitter. The measured signal is converted into the digital signal inside the sensor itself without any external component. Cable is used for the long transmission of a signals. So different type of sensors that is based upon the applications are defined here, like there are many types of the sensors. All these sensors are used for measuring the one of the physical properties, and output we are getting in the another another form, like we are using control system, so the output will we get in the electrical signal. So there are the many sensors which are commonly used in the various applications, and the output or the input will be given in the different forms. So all the sensors are used for measuring the one of the physical properties like temperature, resistance, capacitance, conduction, heat transfer, etc. So one by one we will define that the various type of sensors here. First is a temperature sensor, proximity sensor, accelerometer, IR sensor, that is the infrared sensor that work in the infrared light where the photons are given to the sensor, or the IR, it will work in the IR range, and pressure sensor that measure the pressure, light sensor as we defined earlier, that light dependent resistors, that will be the light sensors, ultrasonic sensor, smoke, gas and alcohol sensor that can detect the gas as well as the alcohol, touch sensor that work on the touch system, color sensor, humidity sensor, position sensor, magnetic sensor that is used in the Hall effect sensor, microphone, sound sensor, tilt sensor, flow and level sensor, PIR sensor, touch sensor, strain and weight sensor. We start from one by one. First is the temperature sensor. As the name suggests, is measure the temperature. You see on the screen a chip or a small device that work as a sensor. The temperature sensor is one of the most commonly used sensor, and the name applies. The sensor will detect the temperature as well as monitor the temperature changes in the atmosphere or in any system. And this temperature sensor comes in a variety of the forms, like it is in the form it comes in the sensor ICs and such as LM35 as well as the DS18B20, thermistors, thermocouples, RT resistive temperature devices and so on. The sensors are forming, temperature sensors are forming in this manner. The temperature sensors can either analog or digital in nature. It depends upon the output. Temperature variation in the analog temperature sensor corresponding to the changes in the physical properties such as the resistance and the voltage. That is used in variety of appliances, electrical appliances like computer, automobiles, mobile phones, air conditioning systems and temperature sensor use. So another common practical use of the temperature sensor is in the industrial temperature controller, like managing the temperature of the devices employed in the manufacturing company. So temperature sensor used in many electronic component and many electronic appliances. Next sensor is the proximity sensor. This type of sensor is a sort of a non-contact sensor and that detect the presence of an item in its vicinity. Like proximity sensor employs a variety of approaches such as the optical, such as infrared or the lasers, sound, magnetic Hall, capacity and so on. So proximity sensor are used for detection of the objects or an item. There are the different applications of the proximity sensor, which includes the parking sensor, object alignment in the industry as well as the ground proximity detection in the aircraft. Another common application of these sensors lie in the automatically shutting and opening of the doors. Like as we see in the malls, we use a sensor. That sensor is the proximity sensor, and these doors close and open depending upon the body movement near it. Next is the IR sensors. These IR sensors also known as the infrared sensors. It is the light based sensor and utilizes in a variety of applications such as proximity and the object detection. So IR sensors can be used in the detection of the object nearby it. So infrared sensors are classified into two types. First is the transmissive and second is the reflective. So a transmissive type of IR can detect an object that passes in between it and detect the placed opposite to it. And reflective IR sensor detects an object that passes in front of the sensor. Transmissive, between the object passes between it and detector places opposite to it, whereas the reflective IR sensor detect an object that passes in front of the sensor. Here the detector is placed next to the sensor. So IR sensor find many applications in the robots, mobile phone, in the vehicle, for in the parking light, and moreover in the industrial assembly and many more. Next sensor is the ultrasonic sensor that can measure the distance as well as the velocity of the object. Like movement of the object, it operates on the sound waves at the frequencies higher than that of the human auditory range, and the sense can detect the distance of the item by measuring the duration of the sound. The further it can be using the Doppler shift features of the sound wave can be measured through this ultrasonic sensor, and it will calculate the object velocity that can measure the distance in the region and difficult to hard to transfer terrain. This type of. Next is the light sensors. Light sensor, which is also known as the photon sensor, that will detect the light fall upon it. So the photon sensor or the light sensors essential for the many devices. One of the example of the light sensor is a resistor, a light dependent resistors, that is a LDR. The resistance of LDR is inversely proportional to the intensity of the ambient light, which means that as the intensity of the light glow, so does its resistance, and vice versa. If we are giving the high resistance and the light producing the light low, and we can calibrate the variation in the resistance of NDR in the circuit to estimate the intensity of the light. So it is used a photodiode and the phototransistors of used in this type of sensors, and that frequently utilized in the complex electrical systems, and these are both of the type. These are type of the analog sensors. Next is the smoke sensor. As the name suggests, it detects the smokes. Smoke and the gas sensor is extremely valuable in the safety related devices. Like almost all the homes and workplaces, companies have the smoke detectors that detects the any smoke caused due to the fire or the sound and alert. So you see on the screen that this is a smoke sensor that can detect the smoke, that sensor. On the other hand, the large scale kitchens industrial setting commonly has a gas sensor. The gas industries use this type of the smoke sensors. This can detect the LPG. These are the gases which many gases can be detected with the gas sensor. LPG, propane, methane, butane, and many more gases can be detected through this sensor. And series of the sensor is a collection of the low cost sensors for detecting the carbon dioxide, carbon monoxide, methane. Moreover, in the atmosphere, the different type of the gases present that can be detected, that their ratio can be detected through these gas sensors. These sensors can be used in the dye smoke detectors. Next is the alcohol detector that can detect the alcohol and the percentage of the alcohol present in the liquid, that can be detected through the alcohol sensor. This sensor that detect the alcohol, typically alcohol sensor are employed in the breath equipments to assess whether or not the person is intoxicated. So therefore law of enforcement using that type of that is used in the catch for drunk drivers, that detector can be used. So touch sensor where is an essential part of our life. All touch screens gadgets you see nowadays, the mobiles are touch screen, so this sensor are used in the mobile, tablets, mobile and laptops. This touch sensor are used that work on the touch senses. Trackpads on the modern computers are another typical application for the touch sensor. These sensors can sense the touch of a finger or a stylus. So this touch sensor are used. Two types of touch sensors are defined. First, based upon the capacitive, and second is the resistive. So resistive touch sensors detect touch by the responding to the pressure applied on its surface. These sensors have a number of layers, therefore it is not always precise and tends to cause a lot of reflection. And because capacitive touch sensors are more precise and have a higher signal to noise ratio, and they are used in almost in all current touch screen. So in the touch screen, what type of sensor we are using? We are using the capacitive touch sensors. Next important sensor is the color sensor that can detect the color. So color sensor is a valuable device for developing color sensing application, such as that can be used in the image processing industry and the industrial item tracking, color identification and the so on. Example of this type, TCS-3200 is a basic color sensor that can detect the any color and generate the square wave proportionate to its wavelength. Next is the humidity sensor. That sensor which detect the weather and the humidity in the weather that can be detected through the humidity sensor. The weather monitoring system frequency include temperature as well as the humidity data. This shows that the monitoring humidity is a crucial task and humidity sensor help complete this task. And all these sensors related to the humidity, which refers to the ratio of the water content in the air to the maximum potential of the air to hold the water. It means humidity, that water content in the air that can detect through this humidity sensor. Furthermore, because of the temperature effects, relative humidity, practically all humidity sensors can also detect the temperature. The example of this type of detectors are DHT11 and DHT22 are the two most popular humidity sensor among the people interested in building the electrical signal. Next is the tilt sensor. As the name suggests, tilt, it means it detects the inclination or the orientation. The tilt sensor were made from the mercury, but nowadays the sensors are made. Sensors features a roller ball are prepared in the tilt sensor. Next is the speed sensor that can detect the speed. A speed sensor is a little gadget that informs the speedometer. How quickly the vehicle is moving, that the speed detection can be used in the traffic. So furthermore plays an important role in transmission and cruise control system of the vehicle. So these are the sensors, and many sensors we have defined. Further we will define the application and the limitations of the sensor. After that, one by one we will define the various sensor. So today we discussed what are the sensors and types of sensors and classification of the sensors, and various sensors have been defined. Thank you very much.